In this video, I'm going to show you how you can write the equation of a piecewise function when you have the graph. I'm actually going to start with the bottom one. The very first thing I'm going to do is set up my equation. So I'm going to name this f of x, and I'm going to put my brace here. And when I look at this function, I see that I have 1, 2, 3 different pieces, which means I'm going to have 1, 2, 3 different function rules. And each of those function rules is each going to have its own domain restriction. So I need to fill in the blanks here. If I take a look at my graph, I'm going to work my way from left to right. So first I'm going to take a look at the function in between these two dotted lines so that I can write the equation of this piece here. It looks like that domain goes from -5 to -2. And remember, for piecewise functions, we aren't allowed to use interval notation. We really need to use the inequalities. I'm still going to start with my two endpoints. I'm always going to put my x in the middle. And then I'm going to pretend like that x isn't there and figure out which of the two numbers is smaller. -5 is the smaller number, so my inequality has to point in this direction. And if I take a look back over here, both of these points are solid. So I need to put the or equal to underneath my inequality. So for this one I have the domain from -5 to -2, and both of those points can be included. The next thing that I'm going to do is write the equation of this piece. This piece is linear. In fact, all three of these pieces are linear. So I'm going to use either slope-intercept form or point-slope form to write the equation of these three lines. And in all three cases, it's actually going to be easier, based on what they look like, to write the equation in point-slope form. The reason this is going to be easier is because for all three of these, I can't see the exact y-intercept just from looking at the graph. So writing it in y equals mx plus b form is actually going to take more work than it would just to write it in point-slope form that I've written down here. So the very first thing I need to do to write it in point-slope form is to identify the slope. And slope, remember, is rise over run. Rise over run. Or you can use the slope formula. On a graph, I usually think it's easier to do rise over run. So if I look from this point on the graph to this point on the graph, we have to go down 2 units, over 1, 2, 3 units to the right. So my rise over run is going to be down 2 over 3 units to the right. The slope of that part of the graph is -2 over 3. And then I'm going to pick any point on the graph to be my locator point. For this particular graph, I'll use the point -5, 1. That's this point right here that's on the graph. Any point that is on the graph will work. Because it's negative, it's actually going to show up as the opposite on the inside of the parentheses. So I'm going to put x plus 5 plus 1. And that is the equation of this piece here. If I move over to the next piece falls in between this -2 and +3 line. And when I did that, I accidentally marked over that dot. I'm going to erase that. So I'm going to go from -2 all the way to +3. Again, I'm going to put my x value in the middle. I'm going to think about which of the two numbers is smaller. -2 is smaller, so the inequalities have to point to the -2. When I come look over here, the point that's on -2, 1 is an open dot. The point that's on 3, 4 is a closed dot. So the line goes underneath the one that has the 3, the inequality that's next to the 3. Again, I'm going to use point-slope form because I can't tell exactly what the y-intercept is from looking at the graph. So if I count my rise over run, I can go up 1, 2, 3, and over 1, 2, 3, 4, 5. So my slope is going to be up 3 over 5 to the right, a positive slope of 3/5. And again, I just need to pick one single point to put in my function. This time I'm just going to choose this one for a little variety here. This is the point 3, 4. So I'm going to put x minus 3 plus 4. Again, it's minus 3 right here because we do the opposite of what it looks like when it's inside the house, inside parentheses. And that's the equation of that second piece. Moving on to the last piece here. The last piece is going to be in between 3 and 5 on the x-axis. So I'm going to plop down my 3 and my 5. I put my x in between. The 3 is smaller than 5, so I'm going to point the inequality at the 3. And on this one, I have an open dot right here on 3, 1, and I have a closed dot here on 5, negative 5. So I need a line for the closed dot, no line for the open dot. If I count my slope, I can go down 1, 2, 3, 4, 5, 6 over 2. So I'm thinking about a slope of down 6 over 2. If I simplify that, that's going to be a slope of negative 3. Or I could have picked different points to get that right away. And I'm going to pick any point on the line. I'm going to pick, just for funsies, I'm going to pick the point 4, negative 2. So that's this point right here. It's on the line, so it will work. And I'm going to put x minus 4 minus 2. Again, I'm doing the minus here because it's the opposite when it's inside the parentheses. I'm doing the minus here because it is the same as what it is when it's outside the parentheses. So this is the first equation I have. If I come back up to this top one, it's going to be very, very similar, except this time I have a function that doesn't stop. And this should really have arrows on the end of it. If it extends beyond the graph, you can, it's safe to assume that it goes on forever. So for this one, I'll call it g of x, just to name it something different. I'm going to put my single brace. And on this one, I have one piece here, and I have another piece here. So that one's going to have just 2 pieces instead of 3. And it's also still going to have 2 domain restrictions. If I think about the domain restrictions, this graph is split in half on the line x equals 3. If I start with this part of the graph here, those x values, all of the x values that are on the left-hand side of the graph, are less than or equal to 3. And if I take a look at the slope and I pick 2 points, if I pick this point here on 1, 5 and this point here on 2, 3, it looks like I can go down 2 over 1. So down 2 over 1 is going to simplify to negative 2. And I'm going to pick any point, and when I have a graph that looks like this, I'm actually going to choose this point here that's the vertex, and this is going to help you out later on when we learn something different about absolute value equations. So if this is my point that I'm choosing that's on the line, I'm going to write x minus 3 plus 1. When I go to write the other half, so this time I'm looking at this part, this time I'm looking at the x values that are greater than 3. If I count the slope, I go up 2 over 1. So that's a slope of positive 2. And I'm going to use the exact same point because it's also on the line. It's on the different line. It's on this aqua line. And so my complete equation is going to look like this.